is the assignment that I assigned, I believe, a couple weeks ago when I was first gone. Two-way tables, Venn diagrams, and probability. But only 2 of you have completed it so far. So I thought maybe if I went through a question or 2 with you, it would give you a jump start. Now your questions might be slightly different than mine. Okay, so we have a schedule here of babies born in a hospital, Sunday through Saturday. How many of those were actually scheduled to be born those days and how many were unscheduled, and then all the totals. The first question says, in this sample are the events Tuesday and Friday mutually exclusive? Well, babies that are born on Tuesday are not going to be born again on Friday. So yes, I would definitely say that Tuesday and Friday are mutually exclusive events because anything that happens Tuesday wouldn't happen Friday and vice versa. So I'm going to choose yes. Find the probability that a randomly selected baby from this sample was born on Tuesday or on Friday. So on Tuesday, we have 90 babies total out of 500. And on Friday, we have 70 babies total out of 500. Well, for mutually exclusive events like this, we just add the probabilities together. So we have 90 plus 70 is 160 out of 500. So that's 16 out of 50, which reduces to 8 out of 25. I don't know if it's okay with me giving it a fraction, if it prefers a decimal. 8 out of 25 shouldn't be too hard to find the decimal though. I think I just need to multiply it by 4, because if it's out of 25, then 25 times 4 is 100. So if I just take my reduced fraction, 8 out of 25, and multiply it by 4, that should be a 0.32% chance. Not percent, but 0.32 or 32%. It doesn't tell me what decimal place to leave this at, but that one would be an exact decimal. Ooh, gonna check it, crossing my fingers. Awesome. Question 2. The theater director offered every member of drama 1 vote for which play they preferred to perform. The director found that 35% voted for the Odom's Family, that 57% voted for 13th Night, and that 8% did not vote. In this group are the events Odom's Family and 13th Night mutually exclusive? I believe so, yes, because he's just giving them 1 vote, so I think it's either going to be one show or the other, not both. So I'm going to select yes. Find the probability that a randomly selected person from this group voted for Odom's Family or 13th Night. So there were 35% that voted for Odom's Family and 57% that voted for 13th Night. So added together, that would be 35 plus 57, so 12, carried the 1. So that's 8, so 92%, because then there's 8% that didn't vote. So that's another way we could have done it, actually, is by taking 1 and subtract our 8%. Anyway, I added them instead, so that's 0.92, and I'm going to check my answer. A salon owner noted what types of services its clients requested last week. Here are the results. Hair dye was a total of 35% of the customers. Haircut is a total of 30 plus 35 plus 10, so 75%. And then a permanent was a total of 15%. And then this 15% out here means that 15% of the customers fit into categories besides these 3. I don't know what that would be, maybe just going to buy some product or something. In this sample, are the events dye and permanent mutually exclusive? And yes, they are, because they don't overlap. Now, people did get their hair cut and dyed, or they did get their hair cut and got a permanent. But there's no one that got both dye and permanent. Those two circles do not overlap. So I'm going to say yes. And then find the probability that a randomly selected person from the sample requested a dye or a permanent. So dye, we have 5 plus 30, 35. Permanent, we have 10 plus 5, which is 15. So then 35 plus 15 is 50. So 50%, which I'm going to do as 0.5, and then check my answer. "50 people were surveyed about their preference between chocolate and vanilla cake. The following two-way table displays data for the sample people who responded to this survey." So we have those who prefer chocolate, those who prefer vanilla, those who have no preference, and genders and totals. In this sample, are the events female and prefers chocolate mutually exclusive? So let's see, we have 5 that are both female and prefer vanilla. We have 15 that are female and prefer chocolate. So that means that we definitely have females that prefer chocolate. So those are not mutually exclusive. Now, the genders are mutually exclusive from each other, and the preferences are mutually exclusive from each other. But which gender prefers which item? None of those are mutually exclusive. Find the probability that a randomly selected person from this sample is female or prefers chocolate. So we have 22 here that are female, and we have 33 here that prefer chocolate. And so we have this overlap, though, of 15. So if we add these numbers together, 22 plus 33, we have 55. But that doesn't work because we only have 50 people total. And that's because we've counted 15 of them twice. 15 that are both female and prefer chocolate. If we take our 55 minus our 15, and we have 40. So 40 out of 50. So female or prefer chocolate, I believe, would be 0.4. No, that would be 0.8. 40 out of 50, 0.8. I'm questioning if I got this right or not, but I'm going to check it. Oh, I did. Okay,